Today we're looking at the paper Learning Dense Representations of Phrases at Scale by authors from Korea University and Princeton University. The paper is about open domain question answering, where the goal is to answer some sort of a general question, such as what is the population of the United States, relying on a dataset of or some sort of a database of articles containing various knowledge about the world. Typically, this problem of open domain question answering has been approached as a using a two-stage approach. First step being retrieval of the most relevant K articles given a user query. And then second model, a reader model, is processing those K articles to distill the most important information and to generate a answer such as 300 million or whatever the population of USA is. This method has some limitations, most notably that this reader step is quite expensive because it has to be applied to 10 documents, let's say, which have to be processed with this complicated network to generate the answer. And this prohibits the application of this method in applications where real-time processing, real-time responses are needed. An alternative approach, which is considered in this paper, is so-called phrase retrieval, where instead of having this two-step approach, you are directly retrieving phrases from your database that are most likely to contain your target answer. However, this approach to phrase retrieval has typically achieved lower accuracy than the two-stage approach of retrieval and then reading the documents and generating the answer. Because of this, people have typically worked on two-stage approach. However, in this paper, the authors propose a new method which they called DensePhrases, which is able to match the performance of those two-stage methods. And the authors propose a number of tricks to make those phrase retrieval models work well, to learn really good representations, embeddings of those phrases in the database, and then new models which are capable of learning really good embeddings. They also spend a lot of time optimizing those models to make them fast, getting to up to 10 questions per second processing on CPUs, which is quite nice considering that they are working with BERT models, which tend to be slow. And furthermore, DensePhrases improves over previous phrase retrieval models by 15 to 25% in terms of accuracy on some standard open domain question answering benchmarks such as SQuAD. So what did the authors do in a little bit of a more detail? First, they come up with a model that is capable of learning high quality phrase representations. The model is utilizing questions as well as phrases, and basically they generate a lot of questions using a question generation model, from what I understand, using some data available for this, and they train a model to jointly learn an embedding of questions and phrases from a dataset. But the model is obviously very efficient. You don't have to recompute the embeddings for each query. That would not be very nice. Another contribution of the authors is that they come up with a novel method to stabilize the training of this embedding model which works by designing batches which contain negative examples of queries and phrases that are not close to each other. And this seems to lead to a greater accuracy in the final embeddings. And finally, the authors also spend a lot of time on making sure that this method is fast and usable for real-time applications. So these are the main things in the paper. There's a lot of details describing how all of the techniques that they use work for this phrase retrieval and how the model is optimized. In terms of experiments, they do a couple of benchmarks on datasets such as SQuAD, natural questions, and natural questions is a bit longer, apparently, questions. And to sum it up, basically, across a wide range of datasets, here, I have tracked some other ones. The DensePhrases method is matching the performance of the state-of-the-art two-stage retrieval and reader method, which is this one here, state-of-the-art, or as far as I'm aware. While when comparing the dense phrases to the previous methods which take a phrase retrieval approach, we can see that DensePhrases is significantly outperforming them, which is quite nice. It seems that it's really able to retrieve very accurate phrases which match the questions much better. So those are the main things that I wanted to cover from this paper. You can find more details available in the paper, and thanks for listening. Please like and subscribe, and I will talk to you in the next NLP video.